to the countdown.
Tahniah. Siaran langsung ini dibawakan khas kepada anda oleh Akademi YouTuber Malaysia. Sebuah inisiatif e-didik Malaysia dan Kelab Guru Malaysia. Tumpukan perhatian anda. Siaran langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Hello, Assalamualaikum warahmatullahi wabarakatuh. Good afternoon to all the teachers, parents, and the wonderful students. Welcome to Pusat Tuisyen Academy YouTuber, a joint venture with e-didik Malaysia and Kelab Guru Malaysia. Bermula percuma, selamanya percuma. Before we proceed, let us begin with the recitation of Al-Kitab Al-Fatihah. And for the non-Muslims, please recite your prayers according to your religion. So how is everyone today? My prayer is that everyone is doing fine and eager and ready to start our class. But first, let me introduce myself. I am Cikgu Zana, your moderator for today. And together with me in the conti is our controller, Cikgu Wan. Hello, Cikgu Wan. Our observer, Teacher Im. And not forgetting the most important person today is our presenter, Teacher Liu Ailin from SMK Datuk Pengawal Timur, Pasir Gudang, Johor. For the record, we are now live on Teacher's Ailin channel. So as a sign of support to Teacher Ailin for her hard work in preparing today's lesson, so subscribe her channel. And not forgetting to all the teachers who are present here too. As usual, the lesson will last approximately for 1 hour and the certificate link will be given at the end of this class. So be sure to follow the class up until the end and give your full cooperation and full concentration in making this class a lively one. I would also like to remind all the students to use appropriate language and also use appropriate profile picture, if possible, your own picture, if you wish to post comment in the chat box. I'm pretty sure all of you here are excellent students and will uphold a positive classroom environment. So students, please stay focused. And if you have any question, please write on the chat box. And Teacher Ailin and the rest of us here will try to provide you with the answer. So without further ado, let's present and give a warm welcome to our presenter, Teacher Ailin.
Hello. Okay, so now we meet again here. So today, let me see how many of you here. Oh yeah, only 16 of you. So before I start, you can ask your friends, okay, to join us, to join our class. Today, my tajuk, I will be talking about the continuity of functions. That is the first chapter of the second semester. So please ask your friends. So to join us, ask your friends to join us. So if you join us, so we can learn together. Okay. So before this, let's recall back the week before the Sem 2, the first chapter, teacher Im has already taught how to find the limit, and followed by Cikgu Zana. Cikgu Zana was talking about the existence of limits. Yeah. So now I'm talking about the continuous of the function. Okay. So now let me go to the slide. All right. So I'm talking about the continuity of a function. So let's recall back. Since last week, Jekuzana was talking about the existence of limit. Okay, let me ask you. Okay, in what situation? We consider that the limit at a point exists? Can you tell me? You please recall back the lesson that last week. Okay, the lesson of Chekuzana about the existence of the limit. Okay, in what condition or in what situation we say that a limit at a point exists?
Okay, please write down your answer in the chat box.
You write down your answer. How do you know the limit exists? The limit approaches a point exists. Let's recall back the last week's lesson.
Remember last week lesson, the left one-sided limit. Okay, there's one from Muhammad Shafiq. Okay, that's right. La Jayu.
Okay, for Lajayu, the right hand side limit is equal to left hand side limit.
Yes.
Yes. Then Muhammad Shafiq, limit from the left is same with limit from the right. Yes. So this is if limit on the left hand side, limit on the right hand side approaches a point, then we consider the limit exists. Okay, now I proceed to the continuity of a function at a point. Okay, at a point. Okay, if a function f(x) is continuous at a point, so there are three conditions. Okay, there are three conditions. We might miss three. We might have these three conditions if we want to make conclusion that a function is continuous at a certain point. So first condition is Fn is defined. Fn is defined means when the value of x is exactly equal to n, then we substitute into the function, then we find that it is defined. So first condition. Second condition is limit must be exist. Okay, the limit when the x approach to the point n, the limit must be exist. Then the third condition is the value of the limit approaches to the point must be same as the value of the function when the x exactly equals to n. We must have these three conditions. Okay, then only we can say that the function is continuous at that point, x equals n. Then how do you know Fn is defined? What is the meaning of Fn is defined? Fn is defined means when you substitute the value of x with n, then you will get a numerical answer. So if you are able to get a numerical answer, means it is defined. So if for limit exists, like just now you mentioned, for limit exists, you calculate left hand limit of the function as x approach from the left hand side, and right hand limit, the value must be the same. Okay, so when value must be the same, then we say that the limit exists. So when the limit, we can get a numerical answer, means the limit exists. Okay, so then after that we compare the value of define and the limit. If it is the same, then continuous. Okay, now we look at the diagram. So here I'm going to use two methods. One is by using diagram, one is by using calculation. So I go to using graph first. Based on graph, okay, listen, when you look at this graph, so when you look at this graph, when this one means when x is exactly equal to n, the function is equal to m. So in this case, fn is equal to m means it is defined because you can get the value. Then slightly on the left hand side of this point, we find the limit. So that is the limit of the function when the x approach from left hand side. We find that the limit is also equal to m. Then slightly on the right hand side, when x approach from right hand side, the limit is equal to m also. So in this case, we say that since left hand limit is equal to right hand limit, so this situation will let us know that limit exists. That is, the value of limit is equal to m. So therefore, we can make conclusions. The conclusion is the number 3, the third situation, where the limit of the function, the value is equal to the value of the function when x is exactly equal to n. So if the value is exactly the same, then we can say that the function fx is continuous at that point. Okay, so this is the reason why the function is continuous. Okay, when you want to say that the function is continuous, you must mention the reason. This is the reason. Okay, this is by using diagram. Okay, if just now was continuous, now we go to not continuous. So in what situation fx is not continuous at certain point? So same thing, there are 3 situations. Okay, 3 situations where a function is not continuous at a point x equals n. Since if the function continuous, we must have 3 conditions. Same thing, if not continuous means we have also 3 situations. First situation is if fn is undefined. So if fn is undefined means we can make the conclusion that fx is not continuous at this point. Okay. Then the second situation is if we calculate the left hand limit, right hand limit, and we find that the limit does not exist, then also we can make conclusion that fx is not continuous at the point. Okay, this is second situation. The third situation is in case fx is defined, limit exists, but when you compare the value, in case the value is different, then also we say that the function not continuous. Okay, so either one. For not continuous, either one, then you can say not continuous. But if for continuous, the 3 situation, you must meet the 3 situation. Okay, now we go to the diagram. Okay, let's say, okay, class, this is continuous or not continuous? So from the diagram, sure, it is not continuous. Okay, class, how do you know from the diagram the function is continuous or not? When the graph, okay, when you see any gaps or any lobang, okay, like this, means the function not continuous. But what is the reason why the function not continuous? You have to give me the reason in this case. So in this case, what is the reason? You know that this function is not continuous lah. But what is the reason?
Can anybody give the reason?
Okay, give me the reason why this function we say that it is not continuous.
Yes.
Okay, can you say why?
Anybody can give the reason? Okay. Kuyung Jian answered undefined. Muhammad Shafiq said there's a gap.
Yeah, there is a gap, but you have to mention the reason when you write the answer. So the Kuyong Jian, yes, when you answer the question during the examination, you said that it is not continuous. You have to give the reason. Yes, yeah. So for this diagram, fn is undefined. Once you find that fn is undefined, then immediately you can make conclusion that fx is not continuous. You do not have to continue to calculate the limit. Okay, means once you get the function is undefined, then you can make conclusion already. You don't have to continue to finding the limit. Okay, so for this diagram, okay, this diagram also not continuous, but what reason? What reason this? When you write the answer during examination, you have to give reason. What reason you say that it is not continuous? What reason you
Okay.
can give? Someone?
So what's the reason? Okay, write down in the chat box.
Yeah, we have three reason. Yes, not three situation why the function's not continuous. You look at the three situation just now that I mentioned just now. Why you say that? You have to mention the reason. Can you write the
Yes,
reason
please, student.
on the chat box? The function is not continuous. Yes, we know that because got gap, but yeah, but reason you have to give the correct reason.
Clue is you can see the points there. One is unshaded, one is shaded red. GIU answered left hand side limit not equal to right hand side limit. F is discontinued and X equal N.
Left hand side not equal to right hand side. According to Sana's class last week, the conclusion you give limit does not exist. Yes or not?
Yeah. Su
So
Yongjian agreed.
okay, now we look at here. Okay,
Okay.
left hand limit, the value is M2. Right hand limit, the value is M1. So means, okay, first left hand limit not equal to right hand limit. Left hand limit, right hand limit will give you the conclusion limit exists or not. Okay, so means since left hand limit not equal to right hand limit will give you the conclusion that limit does not exist. Okay, then because of limit does not exist, then the function's not continuous. Let's recall back just now we have three situations. Three situations where the function does not exist. Mana dia? Here. Yeah. Okay. We have three reasons why the function does not exist. One is undefined, one is limit does not exist, one is limit not same as the function. These are the three reasons. So when we look at the diagram just now, it is this one, yeah.
So, Teacher Ailin, may I interrupt? Meaning that if
Yeah.
the students just write the left hand side, the left hand limit is not the same as the right hand limit, they will not get the full answer. They will not get the full mark. Is it?
I dare not to say, but to play because I'm not marking,
Okay.
because
But
to
the
play
precise
safe.
to
Yeah,
play
to play
safe, yes.
safe.
Yes, I answer that. Yes, if the students just mention a left hand limit is not equals to right hand limit, they are just mentioning. So the reason is not concrete enough. So they have to like mention that the limit does not exist. Therefore, it is not continuous. That is the complete conclusion. Then only they will get the A1. All right, the full
Okay.
marks.
Okay,
Yeah.
students. Okay, please
So,
mention the reason correctly,
Yeah.
precisely.
Yes, the correct reason for fx not continuous, suppose it is fx does not exist. Okay, that is the correct reason.
Okay.
Because left hand limit not equal to right hand limit will only tell you that the limit does not exist only.
Okay.
That is not the complete answer for complete reason for fx is not continuous.
Okay.
All right. So all right. Okay. Now we continue. Okay. This one also not continuous. But what is the reason? Why? When you answer, you have to give reason why it is not continuous.
Okay, so why it's not continuous?
Okay. You see there is a gap, but when you have to write the correct reason when you say that the function not continuous. Okay. Give me why. What is the reason you can write for this one?
Yeah. Look at the graph again. Okay. And then observe the 3 reasons teacher Ailin mentioned just now.
Just now I mentioned already the three situation
Yes.
where the function does not.
Okay, Jiayu answered limit not equal to f of n.
The third reason where the limit approaches to the point not equal to the fn. Okay, so we see that. Okay, this one means fn is m1. Okay, then n, left hand limit of n, the value is m2. Then the right hand limit, the value is m2. So from left hand limit, right hand limit, you can see that it is the same value. So limit exists. The value is m2. Okay, but when we compare the limit value and the fn, they are the different value. So this is the reason. So you write the value of limit not equal to fn, then the function does not continuous. Okay, so remember there are three situation, three reasons you can use to mention why a function fx is not continuous.
Okay.
Okay. So now remember, okay, there are two formulas that's very similar. So what one is exist. When exist, then left hand limit equal to right hand limit. Okay. When continuous, okay, when the question give you that the function is continuous, then you can use this formula. But the reason, when you want to write the reason why the function not continuous, or the reason why the function continuous, you must go back to the limit and fn. Right? Then another common mistake of the students is when they write this one, they always write fx. Fx is not correct, because the continuous of the function is at the point x equals n. You have to mention the spatial point. Okay, it is not fx. So you must write f and at that point. Okay, this is the common mistake of the students. Okay, so please take note of this one. Okay, so now we go to calculation. Just now was graph. From the graph, you can see whether the function is continuous or not continuous without calculation. But here, we are going to use calculation without using graph. Okay, so for example, determine whether fx, this one function, is continuous at x equals to the point. So you see, x equals 2 is the boundary point of the piecewise function here. So means left hand side of 1 over 2, the function is different from right hand side. So that's why you have to calculate left hand limit and right hand limit. But before this, we know that if you want to determine whether the graph is continuous, there are three conditions. One is when x is exactly equals to 1 over 2. Okay, when x is exactly equal to 1 over 2, you have to substitute it with inside one of the function. Which function you should choose? You should choose the function where you have equal sign. You see here, you have equal sign. So you have to choose 3x minus 1 over 2. It is not the function below. Okay, you choose the function where you have equal sign. So means 1 over 2, you substitute into 3x minus 2. So when x is exactly equals to 1 over 2, 3 times 1 over 2 minus 2 is equal to 1. So since we have got the numerical method, means the fn exists. So the second condition is a limit must be exist. So to determine limit exists, then we go to left hand limit. Okay, left hand side. We approach the function from left hand side of 1 over 2. So first, you have to show you choose the correct function. So x approached from left hand side means x is slightly less than 1 over 2. So when x slightly less than 1 over 2 means you have to choose the function 3x minus 2 minus 1 over 2. So the marks will be given here to show that you choose the correct function. Once you choose the correct function, then you will get a 1 mark here. Okay, you must show you choose the correct function in between these two. So then after that, you substitute 1/2 into the x and you get 1. Means left hand limit is 1. Then we continue to right hand limit. Right hand limit means x is slightly greater than 1/2. So greater than 1/2 means you have to choose the second function. So here you show that you choose the second function. When you write this one means you tell the examiner that you choose this function. If the function is correct chosen, then you will get 1 mark here. Okay, but now then after that you need to calculate. Okay, you need to calculate the value of the limit. If the function has got modulus, before you continue, you must take away the modulus sign. So to do that, then you will go back to SEM 1 topic that is about modulus function. How to take away the modulus function. If you take away the modulus function, you have learned already. Once you take away the modulus function, you will get either negative value or positive value. Okay, so now in what situation this one is negative? In what situation this one is negative? Okay, here. In what situation this one is negative? In what situation this one is positive? Can you tell me?
Yes, student.
This one will go back to SEM 1. You just recall back, do a little bit revision.
Yeah, when you open up modulus.
Now
Last
you
week pun
open the
I did
modulus.
mention. Last week pun ada when we simplified the
Yeah.
function.
Yeah, this kind of question is very popular. They
Modulus.
they know that students are very no good, very weak in this part, the modulus. When open the modulus, they will face
Yeah.
problem. In what situation?
Muhammad Shafiq say choose positive. The below
Choose
one.
positive. I mean, what is the value of x? The
When it's
modulus
negative.
when you open the modulus, you get negative. What is the value of x when you open the modulus? You get positive.
The range of x, the values of x.
I'm yes. So you see the
Okay.
range of x. So when inside the modulus 1 minus 2x less than 0, so it is negative. When 1 minus 2x greater than 0, then it is negative. Then you simplify this part. Okay, means the range of x greater than 1/2, you take negative. The range of x less than 1/2, you take positive. Then when you look at here, okay, then you look at here. You want greater than 1/2 or less than 1/2 depends on you want to find limit. Okay, now you want to find right hand limit. Slightly. Right hand limit means x slightly greater than 1/2. So x slightly greater than 1/2 means this one. You see, it depends on what limit you want to find. So this question you want to find right hand. Right hand side means slightly greater than 1/2. So greater than 1/2 is this one. You have to choose this one. Okay, so you have to choose the negative one. Because right hand limits means greater than 1/2. You have to choose this one. Okay, when you open the modulus. Okay, once you open the modulus, then you rearrange this part. Okay, you find that you can cancel off. So finally, the limit is 1. All right, so when you open the modulus, you have to be very careful. If not, then you will get the wrong answer. Okay, this one is very important. Okay, now we have got the value when x exactly equal to 1/2, left hand side and right hand side. Now we can do our conclusion. Since so now first you compare this one left hand limit, right hand limit, you find that it is the same. All right. So first you have to mention the limit exists. Okay, left hand limit equal to right hand limit will let you know the limit exists. Then the reason. Okay, the reason. So what is the reason? So the function, since the reason, now you compare the limit is 1, fn is 1, that is the same. So this is the reason why you say that the function is continuous, because the value is the same. So you must mention the reason. Okay, the reason have to mention. If you don't mention the reason, then you won't be able to get marks. Okay, so
Alright.
this is the 3 conditions if the function is continuous.
Yeah.
Okay,
Any questions, students?
any
Before we
question?
take a break?
Yeah,
Before we take a break?
Before we take a break.
Any questions? Okay. Nanti
So
dia
now,
clear.
yeah.
Dia
So
crystal
we
clear.
go to iklan.
We go to iklan, Cikgu Wan.
Yeah.
Tahukah anda tuisyen online percuma? Ya, pertama di Malaysia. Gandingan para guru menghasilkan yang terbaik, memenuhi keperluan pembelajaran anda. Semua mata pelajaran percuma. Dibawakan kepada anda oleh Akademi YouTuber Malaysia, Inisiatif Didik Malaysia dan Kelab Guru Malaysia. Tahniah, terima kasih.
Okay, we are back. So we pass on to Teacher Ailin again.
Yeah, then I continue. All right, so now I go to the second example. Okay, now you are given the fx. Okay, determine whether fx is continuous at x equals 3 or not. All right, so now same thing. If you want to determine whether function is continuous, you must test the 3 condition. Okay, let's say I test the first condition, fn. Okay, when x is exactly equal to 3, so when x is exactly equal to 3, so when I substitute into the function, I find that it is 0 over 0. So 0 over 0 when x is exactly equal to 3, that is undefined. So once you get the first reason undefined, means you can immediately make conclusion already. Because in case the function is undefined at this point, you can make conclusion already. Since f3, okay, remember x is equal to 3, yeah? Okay, since f3, when x is exactly equal to 3, the function is undefined, so the function that's not continuous. You must mention the reason. Once you the function is undefined, okay, then you don't have to continue anymore to test the limit. Okay, because the first condition already not we don't fulfill the first condition. You don't have to test the second and third already. All right. Okay, so anything you want to ask?
Students, any questions? It seems that all of them understood. Okay, Teacher Ailin, you can continue.
Okay, so to continue, I go to the second question. No, third question.
Sorry, Teacher Ailin, there's one
Yeah.
from Soliab. No need to do factorization.
Why
This is
do
function.
factorization? Why do factorization?
This is not finding the limits.
Yes, correct. I know, or maybe you see this one is 0 over 0. Okay. When you find the limit, teacher tell you that, okay, when you find limit, when you come to situation 0 over 0, it is indeterminate. Yes or not? That is
Yes.
when you find limit. You find limit. When you find limit, let me see. What I go to.
This is finding the value of the function.
Okay. I want to chonting. How to chonting? Let me see. Wait. Means if you find limit, when you find limit, when you substitute the x into here, you find the equal 0 over 0. That is indeterminate. Yes, correct. That is when you find limit. Then you do factorization. Okay. But for this one, x is exactly equal to 3. X is exactly equal to 3. So when x is exactly equal to 3, so this value is exactly equal to 0. So we undefined. But when you calculate limit, class, when you calculate limit, I cannot chonteng. Can I see whether I can chonteng or not? Let me see. How to chonteng? Let me see. I go to. Wait. How to put down the share screen? How I going to change to whiteboard? Because I cannot chonteng here.
Memang for this display memang tak boleh conteng. We cannot write. It's just manual. Macam last time one shared me the OneNote.
Okay, now I go to.
Stop sharing and then share again the whiteboard that you want.
Okay. Okay, so when you find limit, class, when x approach to 3, okay, x power 2 minus 9, x minus 3. When you substitute the x, you get 0 over 0. Then the teacher tell you this one is an indeterminate. Then after that, you cannot continue. Okay, then you have to factorize. Okay, then you have to factorize. Yes. Okay, like this. Because when we find limit, class, when we find limit, we say that x approach to 3 means x it is not equals to 3. X it is not equal to 3. X it is approximate to 3, either less than, slightly less than 3 or slightly greater than 3 only. It is not equals exactly to 3. So when you substitute the 3 here, then you get 0 over 0. 0 over 0 means when even though we write 0 here means it is not exactly equal to 0. Maybe this value is slightly less than 0. Maybe this value is 0.0001. Maybe this value is 0.002. We do not know. We only know that the value is slightly very approximate to 0 because this x is not exactly equal to 3. This x is approximate to 3 only. So we do not know. Do not know means tak tentu lagi. So that's why we call it as it's indeterminate. Belum tahu lagi because we do not know what is the value. The value is not equal to 3 but slightly less than 3 or greater than 3. What value we do not know. So that's why we call it as indeterminate. But when you go to when you go to stop sharing. Okay, when you come to this one means x exactly equal to 3. So when x exactly equal to 3, so this determinant is exactly equal to 0. So exactly equal to 0, we know that that is the value. So undefined. That is slightly different. This one is not limit. When you find limit means that come up with indeterminate. Okay? So
Okay, they are clear. Okay.
Okay.
Clearly.
Clear. Then we go to the next question. So now function f(x) now determine. Okay, now this question asks you to determine whether the function limit exists. So to determine limit exists, when we recall back Cekuzana, first we must find the left hand limit and right hand limit. Left hand limit. Okay, since you have only one function, means no choice, you have to use this function. But this function has got modulus. Same thing, you have to open the modulus. Before this, once we substitute 0 here, x equals to 2 here, you find that it is equal to 0 over 0. Here it is indeterminate, not because now we are calculate the limit. Okay, so now because since this one is indeterminate, so you have to open up the modulus function. To open up the modulus function, one will be negative, one will be positive. So negative when x minus 2 less than 0, when x minus 2 greater than 0, so this one is positive. So when we simplify, we find that when x less than 2, we should take negative. When x greater than 2, you should take positive. Now we refer here which one you have to take. So you have to see what limit you want to find. Now I want to find left hand limit. Left hand limit means x slightly less than 2. Slightly less than 2 means this one. You have to take this one. So means you have to take negative value. So when you simplify on top, you can factorize. Here, then only you factorize because indeterminate form. So after you simplify, you substitute back the value of x, you find that left hand limit is negative 4. Then next, we need to determine right hand limit. Same thing, right hand limit, you have modulus. When you open up the modulus, which one you should take, it depends on what limit you want to find. Here, you want to find right hand limit. Okay, right hand limit means x is greater than 2. So x greater than 2 means you have to choose this one. Okay, the positive one. So then after that, you simplify. After simplify, you substitute the 2. You find that x is, the limit is 4. Okay, so now you compare because you want to find whether the limit exists. So now you compare the left hand limit and right hand limit. So since you give the reason, since you see the value is not the same, you give the reason, then limit does not exist. Okay. Okay, so first part you have answer. Then under that, hence. Hence means you are going to use the answer just now. State. State means you just mention. You don't have to do the further calculation, means state. Okay, so based on the answer, because the limit does not exist, so we give the reason. The reason now is limit does not exist. Then immediately, since limit does not exist, means you can immediately give conclusion that the fx is not continuous. Okay, then you don't have to go and find when x is exactly equal to 2. That one no need, because you already see this one, the condition, we don't meet the second condition. Then the rest, first condition and third condition, you don't have to calculate anymore. Directly, you can give conclusion. All right. So, okay. Now we go to example number 4. This one, you're given the function fx. Determine whether fx is continuous at x equals 4. So, to determine whether fx is continuous, like just now I mentioned, you must test 3 things. Okay, first thing is when x is exactly equal to 4. So when x is exactly equal to 4, you have to choose which one. You have to choose this one because here, when x is exactly equal to 4, the value of the function is 0. Okay, then the first condition you have got it. This one means if you are able to get the value, means the function defined. Okay, then next you want to find whether the function exists or not. So whether function exists means you have to test left hand limit or right hand limit. So left hand limit. So left hand limit means x is less than 4. When you look at here, when x is exactly equal to 4, we choose 2. X not equal to 4. X not equal to 4 means whether x greater than 4 or less than 4, then you have to choose this one. So since x less than 4 means you have to choose this one function now. So first you show that you choose the correct function. Once you choose the correct function, you'll get 1 mark here. Then after that, on top here, you can factorize, then simplify. After simplify, then you get the limit. Then followed by right hand limit. Same things. You can only have 1 because right hand limit means x greater than 4. Not equal to 4 means either less than 4 or greater than 4. So means same thing, you have to choose this one. So the same process, okay, same process will same as just now. Then you find that the limit is 8. Okay, so now class, when you compare the left hand limit and right hand limit, yes, it is the same. So means limit exists. Okay, limit exists. Then after that, now the question asks for continuous. Okay, so the first condition you have got it. The second condition you have got it, means the limit exists. Then only you go to third condition. Now third condition, we compare the value of limit and the value of function when x is exactly equal to 4. You find that the value is not the same. So you give the reason. You have to give the correct reason. Okay, give the reason. Since the value is not the same, then you give conclusion that the function is not continuous. Okay, so example number 2, number 3, number 4, I've shown you the 3 situations where the function not continuous. All right, so at the moment, anything you want to ask?
Yes, student. I think they all understood crystal
Okay,
clear.
so then we continue to
Yes.
the example number 5. Okay, so now you're given the function gx. Okay, here. Then here you have a unknown k here. Okay, this kind of question is very popular, very frequently asked. Okay, you have an unknown in the function and you're asked to find the value of the unknown here. You're given that g is continuous at this x equals -3. Okay, so first step you have to calculate what is the formula you should use. The important thing is you're given gx is continuous. So we know that if gx is continuous at this point, what is the formula you have to use? What formula you have to use, class? Can you mention? Write down the what is the formula you have to use if you're given that gx is continuous at this point, x equals -3. You have a value. What is the formula?
Yes.
Yeah. What formula you should use?
Remember the 3 conditions?
Can you write down the what formula you can
First
use
one,
for this question? Maybe in the process of
Muhammad Shafiq use Fm equal L.
Fm equal
Uh,
L.
I think
Fm
find the
equals L
find F3.
is the only first condition.
Okay, so
Fn is equals L is the first condition if the function is continuous. If the function is continuous, we must have 3 conditions.
So solely answered right hand limit equal left hand limit.
Right hand limit equals right hand limit will give you what conclusion? If you say only left hand limit, right hand limit only.
She mentioned all function is equal to limit of the function. Fn.
Fn is equal to
the limit of the
Fn.
The existence of the limits.
Yeah. Yes. It is correct, but we know that fx is if we know that it is continuous, means fx, the limit of fx exists. So if the limit of not fx, if the limit of gx exists, means the left hand side is equal to right hand side. So this part will give you the function gx exists. Then must be equal to the gn. Yes, correct. But the only thing is because this is this piecewise function, what? Okay, because this one is piecewise function, so means you have to calculate left hand limit, right hand limit. Okay, continuous, the formula is this one. So means since you are given the g is continuous, so first you calculate the value of the function at the point from left hand side negative. Okay, so you calculate this one first. Okay, so to calculate left hand limit, so you must choose the correct function. Okay, left hand limit is x slightly less than -3. So you see here, you look at here, x less than -3. This function is x greater than -3, less than 3. So which function you need to choose? I think I have to be fast. Okay,
Yeah.
tell me the first function or the second function for left hand limit, class.
Okay, just say first or first or second.
Which function you have to choose when you want to calculate left hand limit?
Left hand limit.
First function or second function?
Left hand limit means slightly less than 3. Negative.
Yeah.
Slightly less
Oh,
than negative 3.
yeah.
Slightly less than
Less
negative
than.
3.
So
Okay,
less
Ku
than
Yun Jiang
-2.
mention second, so Liep mention second.
Yes, you have to choose second because the first one is for greater than -3, less than 3. So less than -3, that is this one. Okay, so first you choose the correct function. Okay, when you choose the correct function, you get 1 mark. Then the problem is if you want to continue, you see here, there is a modulus. Then you have to repeat. You have to open the modulus before you can continue. Okay, so same, if you open the modulus, you will have 1 negative, 1 positive. Okay, negative is when 2 minus x less than 0. Positive is 2 minus x greater than 0. Then when you simplify, x greater than 2 is negative, x less than 2 is positive. So now you want to choose which one, negative or positive. It depends on what limit you want to find. Now you want to find left hand side. Okay, that your value is slightly less than -3. So slightly less than -3, you see the -3 is in which region? -3 is in which region? In the region x greater than 2 or in the region x less than 2?
-3. Which region, student?
Now you want to find the first one or the second one? You want to choose negative or positive? It depends on what limit you want to find. You want to find -3. When x slightly less than -3, it is in which region? In the second region, x less than 2. Okay, so means you have to choose the positive one. Okay, so when you choose the positive one, now you substitute x with -3. Now you get 5 plus k. Now you leave it there. Okay, now because there is a unknown here, you want to continue later. Okay, next we are going to calculate the right hand limit. Okay, left hand limit you have got it. Now we have to calculate the right hand limit. Okay, so right hand limit, which function you need to choose? Which function you need to choose? The first one or the second one?
So which function, student? I think that one was the previous left hand limit, Ku Yun Jiang. Now it's for the greater than -3.
Yes. Yeah, first one. Because when you find right hand limit, yes. Yeah, correct. Because
yes, correct.
correct. X greater than -3. Okay, right hand limit means x slightly greater than -3. So x greater than -3 is this one. So means you have to choose the first one. So you choose the first one. Once you choose the correct function, then you get marks. Okay, then after that you substitute the -3 inside, then you find that it is equal to 0. Okay, then after that you can compare the left hand limit and right hand limit already. Okay, then here, class, I know many of you, when you got left hand limit, right hand limit, you will directly say that 5 plus k will be equal to 0. Directly, you say that k is equal to -5. So please do not write that. You have to mention in what situation, why do you say that 5 plus k is equal to 0? You must write the formula out. Because you are given the g is continuous, you have to write this formula up. It's very important. You must write. Cannot directly say that 5 plus k is equal to 0 without writing this one. Okay, I repeat that 3 times. You must write this one. Is very important. You must write this one. Okay, without writing this one, then you will lose mark. Okay, without writing this mark, you don't show that. Then now, who tell you 5 plus k is equal to 0? Okay, so you have to write this situation because you're given that g is continuous. When continuous, this is the formula. So based on this formula, Now, left-hand limit is 5 plus k. I write here. Right-hand limit is equal to 0. Now you have 3, yes or not? You simply choose 2. Now I choose left-hand limit and right-hand limit to do the calculation. Okay, then only you can say that 5 plus k equal to 0. Okay, remember this one you must write. Then, okay, from here, then only you say that k is equal to -5. Okay, without writing this statement, you will lose mark. All right, so please, this one is very important. I repeat one more time. Okay, so up to here, any questions? I think I'll go to the last example because it is almost time already.
Yeah.
All right, the last question. Okay, now you are given the gx is this one. Okay, now determine the set of value of k. Again, you are asked to find the k, but now you are given this continuous. Okay, because now we are learning the continuous of the function, whether it is continuous. Sometimes the question in the Stpm will reverse back. How about discontinuous? Discontinuous means not continuous. Now you're given that gx is discontinuous. Then what's the value of k, suppose? All right. So now we must recall back. What are the situation the function not continuous? There are 3 situations, yes or not? There are 3 situations where the function not continuous. First situation is the function does not define. First situation is the function not defined when x is equals 4. So we want to double check, is this the reason where the gx is discontinuous? We need to double check because you can use 3 reasons. What? Okay, we got to double check. Okay, is it possible the gx undefined? Undefined means the fraction, the denominator of the fraction is 0. We see in k. Since x is, you see this one x is greater than 4, x less than 4. You are given that x is equal to 4. X is equal to 4 means this is the function you need to choose. Then you see, is it possible this function equals to 0? Okay, since x is equal to 4 and k will not equal to 0, so means this function will surely it is not undefined. See not? K is not equal to 0. X also not equal to 0. So this function, the first condition cannot be. Means this function will be always defined. Always defined. Because k is not equal to 0. X is not equal to 0. So the first condition, it is not the one. Okay, don't go to the first condition. Okay, now we go to the second. Okay, then we can say that G is discontinuous maybe because of the second situation where the left-hand limit is not equal to right-hand limit. So we need to calculate. Okay, now we calculate. So we calculate left-hand limit. Okay, left-hand limit. So the function that we choose is this one, less than 4. Then we substitute the value. Then we get 2. Then right-hand limit. Then we choose this function. Then we substitute the 4. Then when we simplify, then get this one. So, means since the question gives you that the function g is discontinuous at this point, so means the second reason, that is the limit does not exist. Limit does not exist means the left-hand limit is not equal to right-hand limit. Okay, so now you plug in the left-hand limit not equal to right-hand limit. So therefore, in this situation, k is not equal to 3/2. But when you write your final answer, since the question asks for set of value of k, so your final answer, therefore, the set of value of k where this gx is discontinuous, that is x, that is k less than 3/2 or k greater than 3/2, but not equal to 3/2. That's it. Okay. So I think I because it is already time, so I think my lesson is up to here. So anything you want to ask?
Any questions, students? I'm looking at the comment.
So
Okay.
then we will finish here lah, I think.
Okay, we stop here. Okay. Thank you, Teacher Ailin, for sharing all the tips. Okay, remember the 3 conditions for the definition of continuity of functions. Okay, right. We got grace. We have reached the end of today's section. So I would like to congratulate to all the students who have able to follow all the session from beginning till the end. Before we end our session for today, all right, can you all please subscribe to Teacher Ailin? Click the activate the icon bell so that you will not miss the next lesson. So can you please do so? Okay, once this is for the new subscribers. Okay, for those who have not subscribed to Teacher
Yes.
Ailin.
Please
Okay, please
support.
subscribe. Support us, because when you support us, we have the extra energy, motivation, to do more,
Yes.
to do more videos for you.
Yeah,
So,
correct.
right. Okay, can you type done once you have subscribed, Teacher Ailin? I want to see a few supporters here. Please type done. Say type done once you have subscribed Teacher Ailin's channel. Can you type done in the comment on the comment box?
Maybe they have already subscribed.
Okay, hopefully they have subscribed to Teacher Ailin's channel. Okay, right. If you find that the lesson was beneficial, click like and share to your friends on your social media. Okay, please spread and share the goodness. Okay, right. The certificate link, can you please paste on the comment board? This is as a token of thank you for your dedication in joining the free online class today. Okay, can I look back? Okay, Kru Yong Jian, thank you for typing done. Okay, when I see done, not only I feel happy for Teacher Ailin because the support that you gave to Teacher Ailin and us. Okay, the certificate link is already in the chat box. Okay, right. Please take note. The link will end half an hour after this live, so make sure to use the EDD email only to log in, because incorrect email use will not be entertained. So if you haven't got one, please apply. Okay. All right. You can, if you wish to get more information, you can go to www.academyyoutuber.com. And for those who haven't joined EDD Junior Telegram, please do so. Right. Before we end, let us hear a few words from our teachers here. So let me start with our host controller, Cikgu Wan. A few words.
Okay. Hi everyone. Thank you for participating. I really hope to see you in many more session live streaming for mathematics. That's it. Back to
Okay,
you.
Teacher Im. Okay, thank you, Teacher Im.
Okay, hi. Okay, next week we have a new teacher coming in for our class, and teacher 1, we will be doing going to differentiation next week. The topic's differentiation, and Cikgu 1, subscribe to her. Maybe Cikgu 1 can use your own channel to speak in the chat box so that they can subscribe to you, so that it's easier to find you next week. Okay, so Cikgu 1, next week our differentiation will be on Cikgu 1's channel, and I hope to see you also. Okay, because Cikgu 1 will be joining us for our class starting from next week.
Okay.
Please welcome Cikgu 1.
Okay,
All right.
thank you.
See you
Thank
next
you,
week.
Teacher Im.
Bye.
So once again, I would like to thank all of the students for joining today. All of you are awesome. Good. Feel free to share this free tuition class to your friends and teachers all over Malaysia. This is a collective effort from all the teachers throughout Malaysia for all the students throughout the country. Thank you too for being a YouTuber Academy supporter. Okay, I think that's all for now. See you again next week. Ingat hashtag bermula percuma, selamanya percuma. Assalamualaikum. Stay safe till we meet again next week. Same time, same day. Bye-bye.
Tuition online percuma. Tuition online percuma. Layari www.academyyoutuber bagi mengikuti tuition online secara percuma. Prasekolah, sekolah rendah, sekolah menengah.
Semua ada di Akademi YouTuber. Rujuk jadual di laman sesawang www.academyyoutuber.com. Semoga masa terluang anak-anak anda diisi dengan sebaiknya. Tuisyen online percuma, mestilah Akademi YouTuber.
Dibawakan kepada anda oleh Akademi YouTuber.
Okay.